weeks back I did a race with Andy Green in the Dunlop Radical UK Cup. We shared a car for two 40-minute races at Brands Hatch. Now, if you don't know who Andy Green is, you should. He's the holder of the world land speed record at 763.035 miles per hour, and soon he will drive Bloodhound SSC, a machine that aims to top 1,000 miles per hour, still connected to the ground. He's basically a hero, and he used to fly fast jets for the RAF. The race weekend was a chance for Andy to see how a small race car with wings and slicks would help his training, and for me to pepper him with irritating questions like, "Ooh, does it feel really fast going 700 miles per hour?" Well, this is a kind of video, blog, vlog, pastiche, collection of stuff, whatever you want to call it, from the weekend. And for starters, here's Andy.
The thing probably that surprises most people about straight line racing, world land speed record, is that cars, the faster they go, or like any track car, the lateral corner, tyre cornering or lateral grip, tyre cornering stiffness, whatever you want to call it, goes down. And the faster you go, the less grip you've got sideways. If you're going to extreme speeds, 4, 5, 6, 7, 800 miles an hour, then the car is sliding pretty much continuously at that stage. The wheels are planing on a dry lake bed. The vehicle is moving around in the slightest of crosswinds. Having more paint on one side of the car than the other will produce a side force. There are so many things that will move the car around. And experiencing that for the first time at 600 or 700 miles an hour is inevitable if you're driving a brand new car. Experiencing the sensations of having a car sliding around underneath you, and first of all, not panicking. Second of all, working out whether it's okay and that's normal, so you're somewhere near your stability limit, whether you're actually nice and comfortable or you're over your stability limit and the car is starting to get away from you, and what you can do about it. And then, because you haven't panicked, putting in the right amount of steering correction or backing off on the power a little bit. All of that decision-making process, I don't have the time to practice at 600 or 700 miles an hour. Coming here to a racetrack and practice going around in circles and scaring myself at 100 miles an hour and getting used to a car that's moving around and recognising whether I've got a bit more to push, whether I've slightly overcooked it and I need to start doing something to collect the car. That the same principle and the same mental process and the same psychological getting used to being a little bit scared but not too scared, being right on the top of the stress performance curve. That's a brilliant thing to practice at a weekend. And as you and I are both discovering, the Radical is a great car to practice it in because it is quick. Its handling does change with speed because of the aero package, and that actually is quite useful for me. I haven't done that before. And it's relatively forgiving. We've both been backwards down the main straight. That wasn't intentional for either of us, but we both learned quite a lot about it, and the car's forgiving enough that it's out there now ready for the race.
So the race weekend was a pretty normal setup. Test Friday, qualify Saturday morning, race Saturday afternoon and Sunday. This is the car we were racing, a Radical SR3, which to me is the classic Radical. A tweaked Suzuki Hayabusa motor taken out to 1500cc, that's 210 horsepower and 130 foot-pounds of torque. The car weighs just 570 kilograms and, as you can see, it has a load of aero. It has a paddle shift gearbox and it runs Dunlop slicks. The challenge with the Radical is getting used to the downforce. Even compared to a fast GT car, the turning and cornering speeds are breathtaking, and you have to take a leap of faith to find the limits of grip. The braking performance is startling too. It only has little 260mm steel rotors, but it'll pull 2 Gs under brakes all day long. From very high speed, you also have some aero effect, which allows you to use big initial pedal pressures, but not that big, as you'll see later. Friday was a chance to get comfortable in the car, or as comfortable as two people sharing a drive who are about 8 inches apart in height can be. You see, I was wedged forward with a load of foam. Brands Indy is an evil circuit. Andy worked his way into the car, I did the same. In the last session I pushed harder in the braking zone into paddock because that's where I was losing time. I found some time, but sadly I lost the car. Now, Radical were understandably miffed at me wrecking the rear end of the beautiful Bloodhound liveried SR3. They went and found more stickers for the next morning's qualifying session. I went to look at the data. Too much brake pressure, plain and simple. Didn't feel like it from inside, but the numbers don't lie. The rear's locked and my neck got stretched. This seemed like a good time to ask Andy what it's like to go really fast. I just find this stuff mind-bending.
You had opposite lock at how fast?
Around about 600, between 600 and 650 miles an hour.
How much lock do you have to apply?
Well, the steering for the car is about half the, it's about twice the ratio of a road car, so you get about half the wheel response. So for a normal road car, you've got 90 degrees of lock on, you get about 6 degrees at the rear wheels. We had a 30-to-1, so 90 degrees of lock, which is what I had on at 600 miles an hour, is about 3 degrees at the rear wheels, and we're rear wheel steering. That is part of the problem. The twin jet supersonic car we built last time had so much jet and structure at the front, there was no room for the steering gear, just enough room for the wheels, so the wheels were behind me. So every time you put in a steering input, the car moves the wrong way before it starts to go, which is quite confusing for a simple brain like mine at 600 miles an hour. And to add to that, aerodynamically the car became unstable in the transonic region. Not uncontrollable, and the difference is, push bike at slow speed, you can actually ride a push bike. If you let go of the handlebars, it falls over. It's controllable, but it's not stable. Yeah. Multiply that up to 600 miles an hour, and I had much the same problem of fighting the car. And it set off sideways, usually left because of the aerodynamics, and I ended up putting 90 degrees of lock on and backing off on the power to just try and change the front-rear balance a little bit and get the weight off the front so that we finished up with a better balanced car. As soon as it started responding to the steering, because we've got about probably 2 or 3 degrees of yaw on now as the car's sliding sideways, and it's about 15-20 metres offline. As soon as it starts responding and coming back, I've got to get the power back down again because I've only got another 1.5 miles to the measured mile. I've got to get up above 750 miles an hour. So it's full power, start to wind the lock back off so that I get the car straightened up on the line going into the measured mile at supersonic speeds. And of course I've got to do that 2 ways within 1 hour to set the world record.
This was my qualifying lap. I'm a bit of a pussy through paddock, I have to admit, but it left us 13th on the grid. Andy qualified for the first race, I did the second. Neither of us made much of an impression on the computer screens. His excuse was valid. He hadn't raced a car at Brands before, and this was only his second event. Mine was more tenuous. I felt that if I bent the car again, I was probably a dead man, and the combination of seat and downforce was plain torture.
Because we're both learning that the Radical may be a small car, but it has quite significant aero effects here in 2 places, Paddock Hill and down at Surtees. For me, an aero effect on a car is when the car forces you to do something that your brain tells you shouldn't. To turn in at a speed that mechanically you think is not suitable for the vehicle. That means that wings are working. Yeah? Is that a reasonable description of it?
Absolutely right, and the classic here is coming into at the bottom of Brands Hatch, the sort of S-bend Surtees for those that have driven it here. And I was, first day I was braking quite hard. By the time I got to the end of the first day, you can go through there almost flat. So I'm braking a little bit. Now I'm just lifting very slightly, and the car is going through like everybody promised it to be. But it doesn't make sense. The performance of the Radical, loaded up at best part of 100 miles an hour, it just does stick to the tarmac astonishingly.
Where we had a discussion yesterday about the aero when you go to 1,000 miles an hour. That's remarkable. So talk us through the speed ranges of the car.
Yeah, first of all, the aerodynamic forces are absolutely dominant at the high speeds. I mean, to go back 15 years to thrust SSC, 1 degree nose down would generate 10 tons of download on the front and crush the front suspension into the desert. 1 degree nose up would generate 10 tons of lift, car would pitch up, pull 40G, bodywork comes off, engines tear out the bottom of the car. That's the end of my interest in the afternoon. So that precision, it needs to be incredibly precise. And with the thrust shape 15 years ago, we didn't have the tools to set that so that it was the same angle all the way through. We actually had to change the pitch angle of the car as it was accelerating. The problem with that is if that system fails, you finish up in an uncomfortable place. And we limited it with Thrust SSC because we were only just going supersonic. Step forward 15 years, we're now trying to do 1,000 miles an hour. That's almost 40% above the speed of sound, Mach 1.4. So tweaking the car a bit isn't a solution. We're actually going to have to solve the fundamental problem of a shape which generates virtually no lift or downforce all the way through the speed range. And that's been the single most difficult technical problem we've had. We've had Swansea University, who are the world's leading experts in this. They developed the technique 15 years ago that we used. Intel have given us a huge amount of computing power, and we've done some genuinely world-leading modelling, supersonic ground effect, and got a shape which at all speeds will stay on the ground. And that actually, when you think about it, is the only safety requirement for a land speed record car.
Yeah.
As long as you can keep it shiny side up, keep all the wheels on the ground, and the fin is the right size to keep it pointy end forwards, you've cracked it.
But you don't want to drive it into the ground so hard that it disrupts the surface and makes it unstable.
Exactly, and that's why the aerodynamics have to be so precise to actually bound the load, so you don't crush the wheels, but you don't at any stage finish up with them lifting. Or with the front-rear distribution so far out, particularly front-heavy, that the car becomes uncontrollable as a vehicle. Because before it becomes totally dominated by the aerodynamics, which is sort of 500-600 miles an hour high speed bit, at 300 or 400 miles an hour, which is slow to medium for this car, it is behaving like a car at least as much as it's behaving like an aeroplane. So it's dominated by its vehicle dynamics as well, and we need to get that balance right.
300 to 400, slow to medium speed. It's a different reality, isn't it? Anyhow, back to the racing. Andy started race 1 and in the dust and mayhem held his nerve for 20 fraught minutes before handing over to me. For his first time in a fast racing car, it really was a stellar effort. The change was reasonably smooth, but there was a problem with my reproductive equipment. My right spud was being crushed by the belts. This was agony, so I tried frantically to adjust on the small straights. It didn't work. I then got overtaken a few times. The only thing for it was a pit stop for testicular adjustment. As racing driver excuses go, you have to admit, it's pretty good. We started 16th, we finished 15th. Anyways, this is Andy talking about rear suspension design.
We had to have the rear wheels outside the bodywork. First of all, because the shockwaves under the body will tear up the desert. This is a dry lake bed we're going across. The front wheels and the shockwaves between them will rip up the surface they're running over. So we need some fresh surface outside the bodywork for the rear wheels to run on. And we need them wide enough apart that we've got some really good rollover stability, so that even if the car does get a little bit sideways, there is no chance of it digging and rolling over. So we've got a 50% safety margin on the rollover stability. Pushing the wheels out puts the struts out into the airflow, and the shock waves over them, the sudden deceleration of the air as it supersonic as it hits those struts, sudden slowdown, the pressure goes up. It's like traffic suddenly stopping, all the cars compress. Finish up with a high pressure reads around the back of the car, gets underneath the car, lifts the tail off the ground. Now the way to fix that, simple way, is to angle the struts down. Problem is when you're subsonic, say 600 miles an hour, no shock waves, so no high pressure, but the angled down struts are now generating 10 tons of download. So you've got to find a solution that works subsonic and supersonic. And although it was a combination of things, part of a significant part is it's a double wishbone. So you've got a pair of struts at the top, a pair of struts at the bottom supporting the wheels. That pair at the bottom we've filled in, so it's almost like a big delta plane, like a Vulcan wing.
Race 2 was a little more straightforward because I didn't have any knacker problems. This time I started and Andy took over. We started in 13th, we finished in 13th, and everyone was very happy indeed. Now I hope you'll join me in wishing everyone involved with Bloodhound the very best of luck. And I want to leave it here with Andy talking about the numbers involved in Bloodhound, because that's what it is really. It's a collection of amazing numbers, and that's what always captivates us about the land speed record.
Our car's going to have 3 engines. It's got a state-of-the-art Typhoon jet engine, 9 tons of thrust, which is about 65,000 horsepower. We've got a hybrid rocket, Falcon rocket, which gives us about 70,000 horsepower. And to pump the hybrid rocket, we've got a Cosworth Formula 1 engine, because we need 700 horsepower just for the rocket pump.